All right, it's time to get started. I'm Vaughn, Vernon, and I've traveled here from Colorado, USA. My talk is Implementing Microservices with DDD and Actors. And you can reach me by email, vaughn@forcomprehension.com, and follow me on Twitter @VaughnVernon. For Comprehension is a company that does both online training and live training, and I have 2 workshops that I give live, which is the Implementing Domain-Driven Design workshop, as well as Go Reactive with ACCA, which is a DDD with actors for microservices class. And I also do consulting around domain-driven design and the actor model. I'm the author of the book Implementing Domain-Driven Design, which is a bestseller. Also, Reactive Messaging Patterns with the actor model that discusses a lot of this information, as well as Domain-Driven Design Distilled, and that's this book, which I'm going to give away a copy of in this talk. Do you find that we tend to be an industry of extremes? An industry of extremes, what do I mean by that? It seems like we latch on to some idea and we kind of take it to the extreme. Let me give you one example of this, acid transactions. Our industry, for whatever reason, perhaps because of database vendors, because of our education, have come to believe that everything must be managed in an ACID transaction. Even to the extent where if we have systems that are collaborating together to accomplish a specific use case, that all of these services together must commit the data of a given business use case in a single transaction. It's called XA, or global transactions. I think that this is an extreme viewpoint. One reason for this is when you ask the question, how did business function before databases, before computers? Did businesses require all things to be consistent all at once, or was there some sort of time lag? There was an obvious time lag because the way a lot of businesses worked in their workflow was for paper to be routed from inbox to inbox on top of someone's desk, and it just required time for everything to reach consistency. Now, some businesses today don't really have that situation because they were created after the computer revolution and exist because of the internet, because of SaaS, software as a service, and so forth. But if you go back to traditional businesses and ask them, you'll find that business was not consistent. There was no notion of ACID transactions. It's technology that's brought this upon us. Therefore, actually, everything in business used to be eventually consistent. Why can't we use eventual consistency today more often? I think that if you have conversations with business people, you'll find that there is some time frame in which systems or services can be brought up to date or in harmony with each other within some known business acceptable time frame. Another extreme that we seem to latch onto is the size of a software subsystem application. Do we design monoliths, or do we design microservices? There seems to be a camp that says monolith is good, microservice is bad, and there's another camp that says microservice is good, monolith is bad. But what is the size of a monolith, and what is the size of a microservice? The problem with a monolith is that you stand a very, very good chance of creating what's known as a big ball of mud. This is where you have many tangled models, and the tangled models interact with each other in a very confusing way. Practically speaking, sometimes you change code in one component, and in a completely unexplained, unanticipated place, you've actually had a ripple effect in the code somewhere else in the big ball of mud. Or you modify data in one place in this large tangled model, and that data has a negative impact on another piece of data somewhere else that was completely unsuspected or expected either. Is there an answer to the big ball of mud? Now let me make clear, a monolith is not automatically a big ball of mud. It is possible to design and architect a healthy monolith and a model that you can reason about. However, chances are good that there are still several domain models, logical domain models, that could be separated in a monolith. On the other hand, microservices seem to promise quite a bit. It seems like there's a panacea, a lot of hype going around about microservices. But the question is, what size should a microservice be? Do you know what these three numbers have in common? 100, 400, 1,000? These are actually all line counts. And guidance that I've seen and heard is that a microservice should be no more than 100 lines of code. It should be no more than 400 lines of code. Or it should be no more than 1,000 lines of code. But how can you actually measure the success and quality of a microservice by line count? What if my team says, or my organization says, that I should have no more than 100 lines of code in my microservice, but I create a microservice that is a very worthy microservice that has 150 or 200 lines of code? Does that mean that I failed? Or if I create a microservice that's 500 lines of code, does that disagree with and judge that microservice that it's a bad microservice if it doesn't have 400 lines of code or less? Then the same goes for 1,000. Do you think that these are really good guidances to use for creating microservices? How do we know? A fellow named Fred George takes credit for basically naming and originally describing microservices, the modern microservice. And Fred George says that a microservice should be no more than one page of code. Now, I don't really know what one page means. Does that mean literally one page in your IDE or editor? Does that mean one printed page, so 62 to 70 lines of code? I'm really not sure. But again, I'm not certain that I can put a lot of credence myself personally and the teams that I work with in developing microservices that are 1 page of code or 100 lines of code. The other question is, how many microservices should there be? What is a good number of microservices? The answer could be, what can we keep in our head as developers? What can we reason about? Fred George has actually said that in the enterprises that he works in, they have microservices that are running that they don't even know whether they're relevant or not anymore. But they continue to run them because, why? They're cheap. He says that it would cost about $40 to keep one of those microservices running, even if it's no longer relevant or has any business meaning any longer. They're not even sure necessarily what that service is doing on the business enterprise. But it would cost more to track that service down and undeploy it, take it out of the business operations. So they leave it running. I'm not sure that I'm comfortable with that. Now, this isn't to criticize those who are successful with this approach, because some people claim great success with this. It's just that for my brain, I have a difficult time functioning in that way. One of the reasons is when you think about the infrastructure involved in running so many services, and fault-tolerant services at that, services that won't just kind of, stop everything from working if there's a single node crash. So we need some way to build resilient systems, and when we do, think of the potential for a large number of microservices running, and how will that affect you and your DevOps? So what's practical for the number of microservices? And what does domain-driven design offer that can help? Well, what I'm going to talk about here is bounded context. Bounded context in domain-driven design, I think, is a very worthy boundary for a microservice, and I'll explain why. By the way, if you've read this book, and I think chances are very good that many of you here have read this book by Sam Newman, entitled Building Microservices, Sam Newman says that microservices should be the size of bounded contexts. Now, I think that that's worth listening to because, Sam Newman's book is the #1 Amazon seller under its top category for all technical books in that category, which is pretty amazing. And it remains the #1 seller week after week. So it means that a lot of people are listening to Sam Newman. Sam Newman actually references Eric Evans' book, the original work on domain-driven design, Tackling Complexity in the Heart of Software, and he references my book, Implementing Domain-Driven Design. So to give you guidance, Sam Newman says, we should give serious consideration to bounded context being the same as a microservice. So what is the size of a bounded context that is a microservice? Well, should it have just one entity? Now, I think when Fred George is talking about 100 lines of code or 1 page of code or something like that, Fred George is probably saying that there's just one entity type in a microservice. I suppose there could be more, but when you think about an entity, it's probably 100 lines of code or thereabouts. So that may be what Fred George has in mind. Actually, I say to determine the size of your bounded context, you have to ask the ubiquitous language. The ubiquitous language is the language that the team speaks and develops as a model within a bounded context. This means that within a context boundary, all the terms and expressions within that boundary have specific meaning, have a specific set of behaviors. We know as a team exactly what it means to adhere to the ubiquitous language that is in scope or in boundary. And linguistic components are cohesive. What I mean by this is that if you have multiple entities that collaborate with each other, chances are very good that they belong in the same bounded context. Not always, but often they do. But again, you have to ask your ubiquitous language. You have to have meaningful, productive conversations with the business, with domain experts. Just like you need to have meaningful conversations with the business to find out, can this data be eventually consistent with this data? The same thing goes with the actual ubiquitous language, the linguistics around a bounded context. So, for example, and if you've read any of my books, you recognize this example or this core domain as a DDD bounded context. This is an application that manages Scrum projects. Within this boundary, the term product has a very specific meaning. It is a Scrum product, which means it's the software that some team is designing and building. A backlog item. We all know what a backlog item is. We know what a release is. We know what a sprint is. We know what a team is, a team member, and a product owner. These are all ubiquitous to the language of Scrum. They belong together, they're cohesive. This would be a natural, bounded context, and for that matter, a good-sized microservice. In this environment or enterprise where the agile project management context exists, there are other contexts or other microservices that help it do its job. There's the identity and access context. This is where user authorization and authentication is managed, as well as other information about users. There's also the collaboration context. The collaboration context is where we have forums, where we have calendar entries, shared calendars. We can have forum discussions with posts. And the Agile Project Management context, or microservice, will use the collaboration context to handle threaded discussions and shared calendars and calendar entries for teams within the Agile Project Management context. And then we also have an issue tracker, which is specifically made for tracking defects and feature requests against the software that we're building. So in this case, we have 4 different bounded contexts, 4 different microservices. Let's add a 5th just for good measure and count the components that exist within these microservices or bounded contexts. If you count the little yellow circles inside, there are about 35. So my question to you is, would you rather be responsible for managing, for developing, for deploying, for operating against 5 microservices, or would you prefer to have 35 microservices that do the same thing that the 5 do? My opinion is that choosing 5 is a much safer, much better choice because it gives us the ability to reason about the systems that we're working in. And together, these 5 microservices make up a worthy system, a system that works together as services and that adhere each one to their own ubiquitous language, but it's much, much easier to reason about 5 than it is to reason about 35 separately. So the microservice that I'm talking about is larger than one entity for certain, larger than one entity, but it is far smaller than a monolith. I think that bounded context is a very good measure for what the size of a microservice should be. So I agree with Sam Newman's guidance on that. So think of the ubiquitous language as being greater than just the entity names. And what I mean by this is a bounded context with a ubiquitous language includes the entities, yes, but it also includes things like the command messages, the event messages, other kinds of components that work within the business that is in context within that microservice. Let me give you an example here. This is where we're using a product from the Agile project management context. The product is an entity. In this case, it's also an actor entity. All of the yellow circles that you've been looking at are actor entities, and I'll explain more about actors in a moment. But this actor entity is capable of receiving commands such as plan backlog item, and it also emits events such as backlog item planned. Also, the backlog item is an entity. It has the ability to take a command, define task, and to emit an event, task defined. These are all part of the ubiquitous language. And now, just to make a comment about actors, I really like the statement that Alan Kay, the inventor of the Smalltalk language, said at one time about objects. He said, the really interesting thing about objects is not the implementation of the object itself. And it seems that that's where we put so much emphasis, again, an extreme emphasis on the implementation of the object. He said the really interesting thing about objects is the messages that are passed between the objects. And that is why Alan Kay believes that the actor model really basically delivers some of the basic ideas that he had around object-oriented from the beginning. So actors take messages and emit messages. They receive messages asynchronously, they emit messages or send messages asynchronously. Everything in the actor model should be designed as asynchronous. Another important aspect of microservices is that every microservice should own its database or databases. There should be no microservice or bounded context sharing databases. This is a basic concept behind domain-driven design, to have a strict boundary. Within a bounded context, you have not only your software components that are carrying out the business operations, but even your database schema or database schemas should be completely owned. This is also true of microservices. For example, the domain events that are emitted by actors should be saved, persisted into an event journal. This journal is owned solely by the microservice or bounded context in which it is implemented. And so we have a stream of events being saved to the journal, and then you can publish events out of your microservice to tell other microservices what has happened within your microservice or bounded context as a statement of fact. This happened. You also own your query model. This model is tuned to provide data for views in a specific way that the user needs to see them. So the queries themselves are tuned to contain the data that your screens and reports or your forms and reports need to have. Actors are asynchronous services. If you want to talk about nanoservices, really small services, you can think of each actor in your system as providing nanoservices. Not always will they be in themselves a nanoservice, but for example, product and backlog item are definitely in the category of nanoservices. Now, I like to say never, ever, ever put your brain on acid. And while that is somewhat humorous, it also means that, we should limit our thoughts about ACID transactions. ACID transactions are good. Don't get me wrong. I'm not saying to never use ACID. Obviously, when we have a single transaction where we are writing an event to a data store, even if that data store doesn't really support ACID transactions, in essence, saving that one event to an event journal is in fact equivalent to an ACID transaction. We're guaranteed that that event will either successfully persist or it won't. So ACID isn't bad in itself. It's just that when we try to make ACID prevalent all over the services simultaneously, that's where it causes us trouble. So for example, don't do this. Don't do this. Do not take an incoming request into a microservice. Let's say that the request in the upper left-hand corner is a user interface request. So a browser user has made a request to this microservice. The microservice then updates an entity, modifies an entity, or creates an entity. And then that microservice sends a RESTful request to another microservice directly in order to compensate for the action that was taken in its own microservice. Now, this is not even protected by an XA transaction. This is worse than that. This is where this request, this second request, could fail when the first request succeeded, and now your data is out of harmony within the two systems, and you have no traceability unless your logs tell you that the failure occurred. Does the other service, the original service, the one in the upper left corner, actually know that this request, the second request, failed? Chances are very good it will never know. And this is why teams of developers are assembled within companies just to keep the systems alive. Day by day, they're patching data, they're patching code, trying to figure out why did this service-to-service transaction fail? Why is there data here, but there's not data there? And sometimes the best that teams can do is simply go create or update the data manually through running queries and ad hoc, update the data and make it consistent. Just don't do these kinds of things. This is where I would like to introduce an idea that I think Fred George has really, really right. He says that events are processed within a microservice, they're created within a microservice, and then they are shared with other microservices. And he uses the analogy of rapids, rivers, and ponds. So let me explain this. Rapids is where we have a place to publish all events that happen within some system, a system of multiple microservices. So we're going to publish every event, like you see here. In the upper left corner, a microservice publishes a domain event. It goes to some sort of topic. We're not saying right now what this topic represents in terms of technology, but it could represent several different options, technically. Then, after this event is put into a topic, then the event is published to other microservices. Actually, any microservice within the same system can see every domain event that occurs. This topic that I'm talking about should be implemented through a high-performance message bus. Notice I didn't say enterprise service bus. Message bus. This could be through REST, publishing Atom notification logs. It could be through KAFKA. It could be through RABBITMQ. It could be through ActiveMQ. You have a lot of different options for this, but it must be high performance. The rivers within your system are the actual microservices that have interest in particular domain events. So the events will be channeled from the rapids into the rivers. This is where we will either filter events and dispatch commands or dispatch commands to other actors. So for example, from the topics comes a domain event which will be translated into a command at the boundary of the microservice, and the command will be executed against an entity actor at the heart of the software. The pawns are the aggregate actors or the entity actors, the states, where the states are comprised of domain events. So for example, when this actor entity receives a command, it emits a domain event, and then the domain event is put on the rapids. So you see the cycle. So a command comes in, we emit a domain event from the entity, the domain event is taken from the journal, not taken from it, but read from the journal and put onto the rapids. Note too that channel services may have fewer entities than a typical bounded context, and this is what I mean. If we have a service that makes offers to highly qualified travelers who spend a lot of money and take several trips each month and within a year, we may want to offer them special deals. Are the special deal offers and the reservations for resorts in the same bounded context or microservice? I would say that it's probably narrower than that. You probably want the microservice boundary to be around the offers and a different microservice to be around the resort reservations. So you may have some very small microservices or bounded contexts. Now, I want to make some statements about reactive software development and where I think the Lightbend platform, formerly known as TypeSafe, is a very, very highly high-quality platform to develop reactive systems on. Reactive systems are responsive, they're resilient, they're elastic, and they're message-driven. Responsive. When I develop within a microservice that uses Scala and Akka and the Lightbend platform in general, I often see request-response performance at the point of roughly 12 to 20 milliseconds. This is literally receiving the request, processing the request, persisting and responding to the RESTful user in 12 to 20 milliseconds. Now, what I'll tell you is, if you take your MacBook Pro or Windows machine and go to a medium-sized directory, maybe of 100 files, and use ls-l or dir command, you'll probably find that is about 12 to 20 milliseconds. So think of your RESTful services responding to the extent that you can't even blink your eye and you have a response. That is responsive. Resilient. The really cool thing about the actor model, or one of the really cool things, besides the fact that everything is non-blocking, everything is asynchronous, is that when an actor crashes, it's not the client who has interacted or asked something of the actor that must deal with that crash and know what to do about it. It's the parent of that actor that knows what to do about it. And that is extremely important, because I think you all know, as Java programmers or whatever other language you work in, exceptions that are thrown are very rarely dealt with in an intelligent way. Many times we don't know what to do with the large number of exceptions that could possibly happen. And so what we generally do is log the fact that the exception happens and rethrow. Either we rethrow the same exception or we rethrow a new exception that's in our own context. Having parents handle the crashes of children is extremely, extremely beneficial, because the parent can be tuned to manage what happens to a child, whether it will be stopped completely, restarted, or told to resume without further action. Reactive systems are elastic. Elastic systems grow and shrink on demand. That means that if you need 1,000 nodes in your cluster at any given time to handle the throughput that's required, then you can have 1,000 nodes. If you need only 100 nodes at any given time, then you will have 100 nodes at the time when the throughput lessens. Message-driven. Actors are message-driven, and the rapids are message-driven. Everything in this architecture that I've been showing you is message-driven. So what I want to do now is show you some code. We have just about 12 minutes or so remaining, and I want to show you some code around this use case. This is where a product is created. A user causes a command, the create product command, to be issued. Within this bounded context or microservice in the upper left corner, the product will be told to create. It then emits, as step 2, 2 domain events. It emits discussion requested and product created. This goes to the rapids. Then another microservice reads those. In fact, it's only interested in the discussion requested. This is the collaboration context or microservice, and it's going to create a forum and discussion as a result of that. And then it is going to publish to the rapids a discussion started event. And then as a 5th step, the discussion started event is going to be read by the Agile Project Management context or microservice, and the product will now be brought into harmony with the forum and discussion that was created in its behalf. So let's look at the code. The first bit of code that I want to show you very briefly is basically the bootstrap of a microservice. Every microservice should have a bootstrap. This is a startup runner, and within the Play framework of the Lightblend platform, you can use what's called an eager singleton in order to bootstrap. So what we do is take care of bringing the configuration into place for this microservice. It has a certain configuration, and it's going to listen for events from a central service registry. And the service registry is basically saying, I have the ability for you to look up where other microservices are. Now, you'll actually use that in a very limited way, because most communication between microservices should be through their domain events. But this startup is responsible for registering this service, in fact, the Agile Project Management service, with the service registry. Then we have a products controller. This is a singleton object that runs asynchronously. This service object, or service endpoint for the microservice, runs asynchronously, and notice when we interact with the product actor itself, the product actor is sent a message, and what we get back is not an immediate answer, because that doesn't happen with asynchronous message sending. What we get back is a future, which means that we have a non-blocking controller. The controller code is going to react to when this future finishes. That is, when the actor actually replies, when the product actor replies, then the future will complete, and we'll map that to a result, and we'll form a HTTP response, which is a 201 created with a location header that says, this is where the new product is located. Then we have the product entity, or the product aggregate itself. The product aggregate, notice, is a persistent actor. This actor takes in takes in commands, such as the create product command, and it's going to emit a product created event, and it's going to emit a discussion requested event if a discussion has been requested of that product. After that, the product has the ability to update its own state based on what happened to it. So it actually mutates its own state in a functional way using the events that were emitted from it. The next thing that happens is we have this topics feeder. Every microservice will have some sort of topics feeder that reads all new domain events from the internals, the internal event journal, and it's going to emit or feed each of those domain events to the central topic, that high-performance bus. After that, when there are new events on the high-performance message bus, then a topics reader is going to read all new events that are on that bus, or listen for those, and it's going to then determine, am I interested in those events or not? Specifically, you can see here that we are interested in the collaboration discussion started event, and we're going to harmonize the product based on that event occurring in the other microservice. We're going to bring this microservice in harmony with the fact that a forum and discussion was created. Another interesting part of this is that If need be, if you have a multi-step process involved in your microservice, you can design an actor to be a process manager. This is where the actor, in this case, a forum discussion starter, will take multiple steps. The first message that it will react to is a start forum discussion message. The start forum discussion message will then cause a forum entity actor to be created, and it will send it a start forum command. The forum will then create itself in business terms, and then this process manager tells itself to become another kind of listener. It tells itself to become a forum started listener. This forum started listener will then take as the next step the forum started event, and the forum started event will then cause the discussion to be created, and then this same process manager becomes a discussion started listener, and when the discussion started event is received by this process manager, it says this use case is done, and it replies to the original sender of the start forum discussion command and says that this start forum discussion result is this. It completed. And finally, the product's views. This is where we use CQRS, or Command Query Responsibility Segregation, to take the commands that have entered our journal, been saved by the aggregate entities, into the event journal, and those events are then consumed by various views, and the views project, for example, a product created event, a discussion requested event, and a discussion attached event to the views for querying for the user interface or for reports or for whatever there may be a need. So this is a quick run through of the code, and what I'd like to do is we have just about 2.5 minutes left, and I'd like to take any questions that you have, and then I'm going to give this book away at the very end. So are there any questions about the architecture in general, the DDD approach to developing software, or the Lightbend platform using actors, using the actor model, and so forth? All right, thank you all.